Hello, my name is Tiaja and today I'm going to be talking to you about the quantum theory. The quantum theory is made up of 5 different components, or rules. The first rule is that energy is not continuous, but comes in small discrete units. So energy is not continuous but comes in small units. So pretty much what this would mean is that, let's say this is energy, or let's just make this energy. This is energy. And pretty much what it's saying is that energy would have to come in small units. So it's like imagine like putting a box on these like this. So it's kind of like a factory, you could call it. And let's say in each of these boxes is pure energy, and it's going on the or wherever it's headed to be used, but pretty much it comes in units. So that's the first law. The second, number 2, is that elementary units, or elementary elements act like waves and particles. So elementary elements being light, sound, etc. So elements like light and sound would come in, well, not come, but they act like particles and waves, because quantum theory is pretty much the study of quantum mechanics, which is the study of microscopic particles. So light and sound and other energy forms or elements act like particles and waves. Light acts in particles and waves, and sound comes in, of course, sound waves. That's the second law. Moving on to the third law. Third law is the movement of particles are sporadic. And this pretty much means that they're random. You can't know where a particle is going to move. So, say a particle, let's make a particle circle, is here. It's just about impossible to predict where it's going to go next, because particles are always moving. So, let's say base 1, base 2, base 3. It would be just, 2 more, base 4, base 5. It'd be just about impossible to know exactly where this particle, you can only guess exactly where this particle is going to head next. So it'll head to 5, and from 5 it'll go to 1, and from 1 it'll go back to 5, and from 5 it'll go back to 3. So it's completely random. That is the third law. The fourth is it is impossible to know velocity and position of a particle at the same time. Because the more you know about one, the less you know about the other. If you know exactly how fast a particle is moving, let's say it's moving at the speed of gravity, which is 9.8 meters per second, then it would be, because the more you know about how fast it's moving, you know exactly precisely how fast it's moving, it would be impossible to know which exact position is, because if that makes any sense. So, if you know where the particle is, the more precisely you know where this particle is, the less precisely you'll know how fast it's going. Because if it's going at, let's see, 1,000 meters per second squared, it's not in this exact spot anymore. So if you know it's going 1,000 meters per second, 1,000 meters per second squared, then you have no idea where it's going to be. Here, then here, then here, then here, then here, then it's all over the place. So it's impossible to know both the velocity and or momentum. It's impossible to know both the momentum or the position of a particle. That's the fourth. The fifth one, vaguely simple, which is the atomic world. Is nothing like the one we see. Which means that in the atomic world, which is like, particles and atoms, an atom being like you got a proton and a neutron and an electron. And I believe this is a hydrogen atom right there. But that's pretty much the atomic world. Has a completely different set of rules than the one we live in now. So, here on Earth, or not on Earth, but some of the rules we have is gravity and friction. While in the atomic world, they have different rules. Things don't necessarily apply. That is the fifth law. So, while at first glance, some of this may seem like some crazy theory, it pretty much explains the fundamental nature of particles and waves. I dare to say, it is more important than the theory of relativity. Not that I'm belittling the theory of relativity, but the quantum mechanics is one of the most important aspects in physics. Furthermore, it describes the nature of the universe. So, which adds into the fifth law that there are a different set of rules for the atomic world. And that is the basis of the quantum theory.